So for number 1, they gave you 2 points. They were graphed on this line, so you didn't have to use your slope formula to find the slope, but you could have also done that. Because they gave you the line, you could have just found what the slope was by counting down 5, 6, and right. So this would have been -3/2. Remember to simplify always. If you went the other way, it still would have been the same. You just went up 6 and left 4. But your slope would have still been -3/2. So remember to simplify. Remember to put m equals. That way you know what your slope is when you're talking about slope. Questions on number 1? Say that one more time. So really where you put the negative doesn't matter. You won't see it like this. You really won't see it like this. You'll see it more with negative in the numerator or out. But either of those two. For number 2, it showed this line, just in case you couldn't see it. What would the slope of this line be? 5. Because it is a straight vertical line. For number 3, they gave us an equation. We needed to get this equation in slope-intercept form and then find the slope. So here we have to get rid of this 2/5 by doing what? How will we get rid of this 2/5? So I'm going to take this entire fraction, multiply this by 5/2, which these are going to cancel, and also do that on this side. So I'd have y equals 5/2 is just 5x. 5/2 x squared would be 20. What is the slope of this line? 5. So remember to answer that question. You did have to solve it, but you also had to figure out what your slope was. Number 4, you were given 2 points. You had to use your y2 minus y1 over x2 minus x1 to find your slope. So -1 minus 2 over 3 minus 5 will give us -3 over -2, which would become a positive. Questions on any of these so far? Number 5 was a little challenging because we really had to think about what they were asking. So they gave us 2 points, but within the 2 points we have pieces that are missing. We have to find the value of a, that's our end goal for this. But we need this to have a slope of 1/2. So we kind of have to set up like an equation. If our slope equals 1/2, and we know how to find slope, it would be 5 minus a over 4a minus 2. We're going to have to solve this equation, 4a, and then put it back in and make sure it works. So I have two fractions that equal one another. I can cross multiply. So this would be 2 times 5 minus a, and 1 times 4a minus 2. This would give us 10 minus 2a, and this side would stay the same, 4a minus 2. And then at this point, I can choose whatever I want to move. So which term do we want to move? So we would subtract 10 to the other side. And then because we moved 10 over to the right, we move all of our variables to the left. Subtract 4a. We get negative 6a. And divide both sides by negative 6. So it's saying if a equals positive 2, we should get a slope of 1/2. But then we would need to test that theory. Then our ordered pairs would be 2 and 2, and 4 times 2 gives us 8, and 5. So we would try this again, make sure when we do the slope we get 1/2. If we get 1/2, then all of this is correct. So 5 minus 2 over 8 minus 2 equals 3 over 6. Simplifies to 1. That works, and 2 is our answer. So really the only thing that this is kind of related to slope in regards to is how we set it up. Because if we didn't know how to set it up, we wouldn't be able to solve it. Do we have any questions about number 5? So far in this unit, we've talked about intercepts, how to find it algebraically and graphically. Slope, how to find it algebraically, graphically, and from an equation. Now we are actually going to graph equations. And those are the notes you have on your desk. So if you were working on, before we start those notes, did anyone find any Delta Math or Khan Academy questions that they wanted to go over, had a question about before we start those notes? If you did not have a question on any of those, you do not need your computer, so you can put those away. Later, I'll show you something with decimals, but not a decimal. No, I'm thinking about that. Okay, so you should have notes that look like this. When we are graphing this, our first step is to put these equations in slope-intercept form if they're not already. Many of them will be, some will not be. Plot the y-intercept, so we start there. and use the slope to create more points. We're going to fill up our graph with slope points and then kind of connect the dots. If you would like a ruler, one person from your table can grab rulers for the table. In the colorful part, there are rulers there, but I don't need everyone to go grab one. So if you want a ruler, one person from your table can go grab them. If you don't need a ruler, then it's okay. So for number 1, we have to start at the y-intercept. What is our y-intercept? Positive 3. So plot a point at positive 3 on your y-axis. And then what is our slope? Negative 1. I'm going to write this off to the side just so we have it. So if our slope is negative 1, what directions can we go to get a negative 1? And then up or down. So if I go down and right, this would make a negative 1. So from this point, I'm going to go down and right as many times as possible. Down 1, right 1, and fill up my graph. What other directions could I go to make a negative? Up 1, and left 1. Yeah. So I'm going to go back to my y-intercept and then go up 1, left 1, as many times as possible and fill up my graph. Once I've filled up my graph completely, I'm going to graph a line. Try to make your line as straight as possible. Go through all of your points, and then also make sure your point or your line has arrows, because lines go on forever and ever in both directions, which would mean, thinking back to domain and range, if it goes on and on forever and ever in both directions, domain and range would be what? All around reverse. Yes, I do. Why would we go down 1 and then just go to the right? So since we have this negative 1, remember that slope is always a fraction, rise over run. Your rise is negative 1, your run is 1, or you can think about it the other way. We have to make these negative directions, so down and right or up and left. So down would be a negative, and then right would be the positive. Or we could go up a positive 1 and left a negative. Any other questions on that one? Let's try a few more. For number 2, what would our y-intercept be? Negative 4. So we're going to start there on the y-axis at negative 4. What is our slope? 3. Positive 3. What directions do we go to get a positive slope? And up 1 and, I'm sorry, up 3 and up 3 and 1. The whole numbers are written over 1. how else could I get a positive direction?
Down, left.
Down and left.
So I would go down 3 and left 1.
So in this case, because of where my y-intercept is, I can't go down 3 and left 1 because it would be off the graph. I'm going to avoid going off the graph if at all possible, unless it's like one additional point. So instead of going down and left, we can only go up and right in this case. So we're going to go up 3 into the right 1 as many times as possible until we get done. After you have all of your points, draw a line. Do you have any questions on this process so far? We're going to do a couple more of these. For number 3, what's our y-intercept? So, on the y-axis, plot a point at positive 2. What is our slope? 2 over 5. And again, this is positive. So we could go up 2 and right 5, or down 2 and left 5. Fraction, you have those numbers to go up and down. When it's a whole number, you need to put it over 1. Make sure you're writing this down. So from your y-intercept, count up to the right 5. And then go back to your y-intercept, count down 2 until the left 5. Once you have all of your points, draw a line to connect them. Number 9. What is your y-intercept at number 9? 0. It's 0. It's not there, but when it's not there, it should be 0. That means you're starting at your origin in the center. And your slope here, 4, 4. And it's positive, so you're going to go up 4 and right 1, or down 4 and left 1. As many times as possible. I think you can only go one directions. Once you have your points, questions on graphing so far? Let's go down to number 10. Number 10 is an equation where we need to solve it first and then graph it. So we have to get it back in slope-intercept form before we do anything. So we got to get y by itself, which means we need to get rid of x. How would we do that? Correct. We have 2y equals, I'm going to go ahead and switch these, so it's negative x plus 4. And then after that, what would we do to get y by itself? Correct. So divide everything by 2. This would give us y equals, remember this is really negative 1 x, so this would be negative 1/2 x plus 2. Now, what is your y-intercept? Positive 2. We're going to start there on your y-axis. What is your slope? Which means we're going to go what direction? We go up and left, or down and right. So up 1, left 2 as many times as possible. Down 1, right 2 as many times as possible. Fill up your graph. Once you've filled up all of your points, you can connect the dots. Do one more of these together, and then I'm going to give you time to practice. Number 11 is similar. It's in standard form. We need to get it in slope-intercept form. How would we do that? Or started? Graph 3x. And switch those two so the x term comes first. We have positive y equals positive 3 over 2 x plus 3. Everything will become a positive. Our y-intercept is now 3. We would plot a point at 3. Ignore this black dot underneath on your paper because it's there. Or it might not be seen. Yes. Positive 3 over 2. So we go up 3 and to the right 2, or down 3 and to the right. In this case, we can't go up 3 because we run out of graph space. So we're going to go down 3 and left 2 as many times as possible. And then graph the line through those 3 points. Once you get the hang of graphing, it's not too bad, it's just tedious. really. Do you have any questions on how to graph these equations? I'm going to give you guys the next 15-ish minutes to go through and do any problem we didn't do up here. So that's 4 through 8 on this page. And then back, there are 10 problems. Do as many as you can in the next 15 minutes. Those first, what number is that? 5, and then the back 10. So 15 altogether. Them at about 9. Number 4 should have been a negative line. Number 5 was a positive line. Number 6 was a negative line. 7 was a positive line. And 8 was a negative line. Do we have questions on any of those 5? On the back, 12 was a negative line. The equation you should have gotten after solving was y equals negative x minus 2. If you did not get to the back or were not doing what you're supposed to, make sure you at least have this equation. That way you can go back and graph it later. 13, the equation was y equals 5x plus 5. And it was a positive line. Was negative 4 over 3x plus 4. So the line was negative. 15, your line was, or your equation was y equals positive 1 over 2x minus 2. So the positive line. 16, your equation was y equals negative 1 over 3x minus 1. So negative line. 17 was y equals 6 over 5x minus 3. So you only had like 2 points minus up and one other point. But that was a positive line. 18 was y equals negative 2x plus 5, so a negative line. 19, the equation was y equals positive 5 over 4x minus 3, so a positive line. 20 was y equals 3 over 4x minus 1, so a positive line. And then 21 was y equals negative 3x, or negative 3x plus 0, so a negative line. Do we have any questions on any of those? Yes, I do. Half x minus 2. Let's see the line. Line for 21. So I'm going to show you how you could use your calculator / Desmos. So if you have your calculator, reset it, second, and then plus 712. So everyone should be resetting their calculators, not doing things on their computers. And you'll get something that says round cleared once you hit this button. After you reset your calculator, you're going to go into y equals. If you want to use your calculator, you can only put in equations that are already solved for y. So all your standard form equations, you would have to solve and then put in your calculator. If it was already in number 8, -1 plus x. So I can put in -1/4 x plus 3. The y1 through whatever numbers, those are like your y already. You don't need to put another y in or another equal sign in. This method would really just be to check yourself, did I graph this correctly? After your equation is in here, if you hit graph, it will show you what the line is supposed to be. It doesn't kind of help you find your slope points because those aren't visibly seen. There is a way to change that, and I can remember how to do it. So go to second and then hit zoom. Some of your options aren't the same as mine, but some of them are. If you turn on this one, the grid line, and then go back to your graph. So I just hit enter to turn it on. You can kind of see your slope a little bit more clearly. You'll be able to count it. But this, again, is just to see, did you graph this correctly? If you put it in your calculator and kind of copy the graph, that works as long as you still show me like your y-intercept point and your slope points, draw arrows. Still has to go through the correct points and things like that. And then if you have your computer open or out and it's already like logged into you, can pull up Desmos, and I'll show you the way to do what I do in Desmos. The ones that are y equals, you can graph those, it'll look the same. What's nice about Desmos is that Desmos will graph your equations that are in standard form without you changing it. So like number 12, x plus y equals -2, I'm going to type that in. X plus y equals -2. The points it graphs are only going to be your x and y intercept. What you need is your y-intercept and your slope point. So you can use this definitely while you're practicing. On the test, if you were to get a question like this, you would need to show your work and actually convert it. Could you still use Desmos as like a check? Sure. But you could also use it to count your slope
So I go up and left.
And I can see the y-intercept clearly. So again, use it as a check. You can use it as really a check after you solve it. Put yours in, see if they match. So what would that equation have been? Y equals negative x minus 2. If you put yours and the original in, kind of change the settings. So go into the gear wheel, click this circle, and you can change how the line looks. Say the red one is the original, the dotted line is my solved version. They're graphed on top of each other, so I know they're the same. Next class, we're going to go through graphing by intercepts and graphing straight horizontal or vertical lines. For the remainder of class, you have time to work through the very last page in your notes, practice-wise, or your delta math on on graphing equations. I think the graphing delta math has 4 sections. Either 2 or 3 of them you should be able to do after today. And then your 2 Khan Academies, graphing from slope-intercept and graphing from linear standard form. It's really all we did today. So you have time to work on any of those things. If you have questions, I'll be around. If you did not get the previous Delta Math Khan Academies done, you can also be working on those. Remember, all of those go on this marking period. If you've not taken your Unit 3 test, and you still need to do that, come see me after school today, in the morning, or next week, Friday morning, or next week to do that. But you have this time.